Hello viewers, in today's class we are going to discuss one important conceptual problem from definite integrals, right? And here we have to find the value of k when the value of this integral is given as minus half sine e raised to iota k, right? So here I is the complex number and we are given the value of this integral equal to this expression, and we have to find the value of k, right? And here this symbol denotes the greatest integer function, right? So now what we will do, we'll take this integral as I, right? So I is integral from 0 to 1. Here we have greatest integer 2x, and here we have sine of greatest integer 2x, right? And dx. Now we have to solve this integral, then we will equate the two values and we'll compare them, right? And then we can find out the value of this constant k. Now viewers, in order to find out the value of this integral, we'll make use of the method of substitution, right? And here we'll take 2x is equal to t, right? So we'll assume 2x is equal to t. It means we are changing the variable x to t, right? So now we can differentiate both sides with respect to x. So dt over dx is 2 and dx can be written as dt over 2, right? Okay, now here we see that the lower limit is 0 and the upper limit is 1, right? So we'll change the limits accordingly. So when x is 0, then t is equal to 2 times 0, that is 0, and when x is 1, t is equal to 2 times 1, that is 2, right? So when x varies from 0 to 1, t varies from 0 to 2, right? So therefore now this integral I, it takes the form 0 to 2. Here t varies from 0 to 2, and here for greatest integer 2x we can write greatest integer t, and here we have sine of greatest integer t, and for dx we can write dt over 2, right? So now we can take this 2 outside. We have half 0 to 2 greatest integer t and sine of greatest integer t dt, right? Now here we see that the value of t, it varies from 0 to 2, right? And between 0 and 2 the integer 1, it lies between 0 and 2, right? So what we will do, we'll now split our this integral I as a sum of two integrals, right? That is I1 plus I2. So this is our integral, and this integral will be written as a sum of two integrals, right? So we have half of I1 plus I2, and I1, it goes from 0 to 1 and I2 goes from 1 to 2, right? So now we have half, and here we have 0 to 1 and greatest integer t sine of greatest integer t dt plus 1 to 2 greatest integer t and sine of greatest integer t and dt, right? Okay, so now we have written I1 and I2, right? Okay, now we see that when t, it lies between 0 and 1, right? That is 0 and 1, then the value of greatest integer t is 0, right? Because from the definition of greatest integer function, whenever t lies between 0 and 1, the value of greatest integer t is 0, right? And when t lies between 1 and 2, right, that is t lies between 1 and 2, then the value of greatest integer t is equal to 1, right? So now this expression, it can be written as I is equal to half, and here for this greatest integer t we have 0. So now this integral, it becomes 0 plus, and here we have 1 to 2, and for this greatest integer t we have 1, right? So here we have 1 and we have sign of 1, because here the value of greatest integer t is 1, and here we have dt, right? So now I is equal to half, and here we have integral from 1 to 2 sine of 1 dt, and here we have half. We can take sine 1 outside, so we have sine 1 and integral from 1 to 2 dt, right? Okay, so now here we have half sine 1, and the integral of dt is t, so we have t and limits are from 1 to 2, so we have half sine 1, and here we have 2 minus 1, and that is half sine 1, right? So viewers, the value of this integral, which was taken as I, is equal to half sine 1, right? So this is the value of this integral. Now we are given the value of this integral equal to this one, right? So let us write this expression equal to this one. So now half sine 1 is equal to this value, right? That is minus half, and here we have sine of e raised to ik, where I is the complex number, that is equal to the square root of negative 1, right? Okay, so now here if we compare these two expressions, we have to find the value of k, right? Now we know the famous identity, or you can say the relation, that is e raised to I pi plus 1 is equal to 0, right? So this is the famous equation which connects e I pi 1 and 0, right? So what we will do, we'll take e raised to I pi is equal to minus 1, right? Or 1 can be taken as minus e raised to I pi, and here for this one, that is for this one, we can write half sine minus e raised to I pi, and this can be written as minus half sine e raised to I pi, right? Because sine of minus theta is equal to minus of sine theta, right? And now we have this expression that is equal to minus half sine e raised to ik. Now if we compare these two expressions, we get the value of k as pi, right? So viewers, this is how we find the value of k when the value of this integral is equal to this expression, right? So this is how we solve this important and conceptual problem.